normal forms based on primary keys. We say it as a normalization, right? So initially only I have explained why normalization is required, right? Normalization, before going to the definition of normalization, just I will give one small brief on why we need this normalization, right? So what is the main aim, or what is the requirement why we are going to use the database DBMS application, right? So we are going to store the data in the database, and in order and after storing the data, we are going to perform some of the queries to retrieve those data, right? So many data, like a tremendous amount of data, we're going to store in the database, right? And what is the aim of storing the data in the database? If whenever we require those data, we can retrieve and we can process some of the tasks over on the data, right? So if the data what we are trying to store in the DBMS, it is of huge, right? Anonymous amount of data we are going to store in database. If the data is not in proper manner, nothing but if the data is not stored in a proper order, it is very difficult for us to retrieve those data, correct? So that is the why we are going to use normalization on the database in order to make those data to be in an ordered manner, so that it will be easy for us a user to retrieve or to retrieve the data whenever we require, right? And the main aim of using the DBMS is redundancy, to minimize the redundancy, right? So this by using of normalization of the DBMS, we're going to reduce the redundancy. We are not going to remove the entire redundancy, is not able to remove from the database, but somewhat we can remove somewhat we can minimize the redundancy from the database. And second main important thing by using normalization is we can avoid the data anomalies. We can avoid the data anomalies. What is data anomalies? So we already seen one concept called guidelines, right? So guidelines rules. So guideline one, semantic attributes, correct? So in semantic attributes, we have seen like insertion anomaly, deletion anomaly, and updation anomaly. Right? These are the three anomalies we're going to face in the where in DBMS, in database application. Correct? So insertion anomaly, and these three we set the data anomalies, because whatever the thing we are going to store in the DBMS, all those are in the form of data. So we are storing the data means we are going to face some issues, some problems over the database. That is, what are the problems with insertion anomaly, deletion anomaly, and the update anomaly. Correct? The insertion anomaly. Why when we get the insertion anomaly, we have a table, right? We want to insert a new value to the table. For example, I'll just create one table, employee table I will create. So this table only we can going to use for explanation of the first normal form, second normal form, and all. It will be helpful. So employee table I'm creating. So employee ID is the first attribute name, and the employee name. Then I'll just take phone number, then salary, then address, employee address. Okay, just store the values here. Employee ID I will take it as 10. Employee name, Ram. Phone number I'll just take 888, and the salary is 30K. Address we can take Bangalore, then Karnataka. State is Karnataka. Okay, KR I will just mention KR. Okay, the employee ID. Just I will take one more phone number here. Later I will consider that one. Okay, I will just second one is 20. Sham. Then something like 999. Then 40K. Like Hubli, Karnataka. Then 30. Then you can take 7 50K take say public. Okay, I just take 3 example now. Yeah. So we're going to face a data anomalies, right? Data anomalies. Right. First one is insertion anomaly. Insertion. What insertion anomaly means? If we try to add, see, I have employee name, phone number, salary, employee address. Right. I will just add one more attribute. You can take a department number. Okay, department number. I want to add one more tuple to this table. One more employee I want to add here, but that employee means that employee is not yet assigned to any of the department. That employee is not yet assigned to any of the department, right? But I just know the employee information. Employee ID is something 40. And the employee name is Krishna. Same thing. You can take the name 40. I know employee ID and Krish. Then phone numbers I know 883. Then salary also I know 40K. Then address I know you can take Mysore and Karnataka. But this employee is not yet assigned to any of the department, right? He is a new employee, right? For that employee, the company has not yet assigned to any of the department. So here we need to place it a null value, correct? So this makes a issue here, because placing a null value into the tuple, it is like not a good design, right? So we place it as a null here. This is the one thing. But I know the department number. If you take the reverse of this one, I know the department number. No department has been established in a company, but no other employees has been yet assigned to the department. Then you have to place a null to all these attributes except department number. I just give department number as 05. This is the department number they assigned for a new department, but no other employees has been assigned to this department. Then all these values will be what? All this value will be null, right? All this value will be null. But the thing is that the employee is acting as a primary key here. The main issue is hitting over here, right? So because the employee in employee, if it is acting as a primary key, means we can't able to place a null value. This is one main anomaly, right? One problem we're going to face if we use the insertion anomalies, right? Second is what? Same, deletion anomaly. Second is deletion anomaly, right? If we try to remove, or if we try to delete the data employee information, along with the employee information, the department information also get deleted. That's how will also get deleted, right? That is what deletion anomaly. Third one is update anomaly. Update anomaly, right? If I for example, I just replace this phone number 888 to something like 555. Then if the same value is assigned somewhere 10, right, there also we have to replace the value with old value with the new value. If it is not, then inconsistency will be there in the database. That is the what? Third, that is update anomaly, right? In order to minimize these anomalies on the database, we're going to use a concept called normalization, right? We're going to use the concept called normalization. Normalization is a technique in order to minimize the redundancy on the database, and also in order to minimize the insertion, deletion, and update anomaly which is on the database. That is what normalization. To perform all these things, to minimize redundancy or to minimize the data anomalies on the database, we have types of normal forms. We have types of normalization. Like we have basically three types of normalization. We have basic three normalization we have. That is types of normalization or type of normal forms we can say. First one is first normal form, second normal form, and the third normal form. and also voice code normal form, BCNF. We say it as a BCNF, voice code normal form. Right? By using these normal forms, we're going to minimize the what redundancy and minimize the data anomaly on the given database. Right? We're going to see one by one. Okay. Just I will add few more things in this table in order to explain this first normal form. We're going to explain the first normal form. Right. Here we have two phone numbers. You just consider we have two phone numbers. Okay. Employee ID 10. We having two phone numbers. One is 555 and 888. Okay. These phone numbers we having. These phone numbers are two multiple phone numbers having by the employee ID 10. I will just add one more attribute here. Then which having phone number 978 and 60K. So first one is what? First normal form. 1 NF. We say it as a 1 NF. First normal form. What the first normal form says? Right. We have a database. We have created the database. Now we have to check this database. How we have to check the database before moving to first normal form? We have seen that conversion of ER diagram to relation schema. We have some steps. 7 steps we have. We have just applied those steps in order to convert the ER diagram to the relational schema, right? In one of the steps, we have seen like multi-value attribute and the composite attribute, right? We have seen one, right, multi-valued attribute and the composite attribute. What we did there in that step, we just create whichever the attribute is having a multi-value, right? We just create the new table. Just create the new table in the relational schema by seeing in ER diagram. For example, in a previous example, like we have that location, department location, that is acting as a multi-value attribute. Correct? That multi-value attribute, what we made, we just create a new table. We create a separate table from the present table, from the department table. Right? And we assign the primary key of a department as the primary key to the new table. That is D location, department location. That is multi-value attribute. And composite attribute, for composite attribute, we don't have any specific step, but the name we have directly divided into first name, middle initial, last name, right, in the employee table. So the what first normal form says that the first and foremost rule in the first normal form, we need to disallow or we need to remove the multi-valued attribute. We need to remove the multi-valued attribute and composite attribute and combination of both. And if the table is having combination of both, we need to remove. We need to remove that multi-valued attribute, composite attribute, and combination of these two, which is there on the table. We have to remove that. We have to disallow that time. That is the main aim of using the first normal form. How to achieve this one? How to achieve or how to remove the multi attributes and composite attribute in the given table? In the first normal form, we have different techniques. There are three main techniques. By using those 3 techniques, we can remove the what? Composite attribute and the multi-valued attribute. Here, in the given table, in this table, we have both multi-value attribute also and composite attribute also. Right? In this table, in the employee table, the multi-value attribute is phone number, because the first employee ID 10, we have assigned 2 phone numbers. Means for this employee, he having 2 phone numbers, multi-value attribute for these 2 multi-valued value for this attribute P number. So by using first normal form, we have to remove this one from the table. And second is what? Composite attribute. This e-address. E-address is having the Bangalore is the city and Karnataka is the state. That is why I have given both Bangalore and Karnataka. So that this example will be helpful for minimizing this first normal form, right? So Bangalore is the city and Karnataka is the state. This is what composite attribute. This table is having combination of both multi-word attribute and the composite attribute. We have to remove this composite and multi attribute from this table employee. How to remove? The first technique to remove the multi attribute, right? So the main thing is like in first normal form, the each table or each tuple should have an atomic value. Each table or each tuple should have atomic value. Once we remove this multi attribute from the table, we're going to see only single value, right? We're going to see single value on the each table, correct? So in first normal form, after applying the first normal form on this table, at last we're going to find the atomic values on each table, right? First technique, we can minimize this multi-attribute and composite attribute on the first normal form by using three techniques. The first technique is what? Here we have a phone number, right, and the employer address. So wherever we find this multi-attribute, we just create one more tuple. We are going to mention the one more tuple for the same employee. Example, here I will take what is the first step? Create the other tuple where we find multi-valid. What this says, first technique says, see, I have employee ID, right? I just create the employee ID here. I will copy this one. Employee ID. So here the phone number, the first tuple is having a multi-values, that is multiple values we have. The first rule is what? We need to remove the multi-attribute. So this P number is a multi-attribute. What I will do, I will just create one more tuple for this multi-attribute. Example 10, same thing, Ram. One more value is what? One more phone number for the same person, 888, 30K. Remaining all should be the same. Right? Bangalore, Karnataka. Right? And this is what we are just converted. We are just minimized this. We have removed this multi-attribute by making one more tuple with the same employee. But we have what? Composite attribute. So what we have to do? The same thing. This composite attribute we will decompose. Means I will make this E address as one as city, other one as state. One is city, other as state. So in place of city, I will give Bangalore. In place of state, I will just assign the what? State value. Right? Now, what is the main aim now? After applying the first normal form, in the table, it should not contain what? Multi-valid attribute and composite attribute. After applying this first technique on this table, we can see we don't have a multi-valid attribute, multiple values on each tuple. We have a atomic values. We have a single values on each tuple, right? So now also we have what? This composite attribute we are just decomposed into city and state, so it's also having a single value, right? This is what the first technique is. But here, what is the issue here? We have made employee ID as a primary key. If you make this employee as a primary key, in the primary key, duplicate values will be not there, right? We can't assign a duplicate value, but combine the 10 and 10. But we have assigned the duplicate values, right? 10 and 10. So this normal form will not be applicable. With this technique, we can't be apply on this table, right? So what we can do, if we made this employee as a primary key, we have to combine other attribute. We have to combine other attribute with this primary key. So combination of those two becomes the primary key. The combination of those two becomes the primary key. Here, for example, here we have made employee ID and phone number. These two are the primary key, right? If we made these two as a primary key in this table, right? Employee ID and phone number. So now we can apply. Now we can apply this technique on this table, because combination of employee ID and phone number is what? 10 and 555, right? Value of these two is what? 10 and 555. Now value is not same, values differ. 10 and 555. So this technique, if you want to apply this technique on the given table, if they're having a multi-value attribute, so we have to make the primary key with, we have to combine the primary key with the any other attribute in the given table. Then only we can apply this technique on this table. This is what first technique. Second technique we have is here the phone number is what I'm making the issue, right? This phone number is having a multi attribute, so we have to take the same step as we are doing in the conversion of year diagram to the relation diagram. What we did there, we just create a separate table. We have just made a separate table, right? We have just made a separate table by making the primary key, of the present table with the new table, correct? So here we can make this employee ID. We can make this employee ID. Then okay, employee ID, then phone number as a new table, So after creating a new table, what we get? This 10 followed with the value 555, then 10 followed with the value 888, then 20 followed with the value 999, like that it will continue. 30 Krishna 777, 40 Krish 978. So these two becomes the what? Primary key for the new table. You just take this table as employee phone, EMP phone. We're giving a new name for this table like employee phone, right? So now this employee ID and combination of these two becomes the what? Primary key for this table, and this is the partial key and this is the primary key. This employee ID we have taken from the what? Parent table, right? Parent table. So this becomes the foreign key and this becomes the primary key. If you want, we can join these two. After joining, again we will get the same table. The same table we will get. This is the second technique. What second technique said? Make a separate table. Make a separate table. This is second technique, right? After this one, the third technique is what? The third technique, we have the phone number, right? We have phone number. This is having a multi-value attribute. Multi-value we are facing here is this attribute as a facing first normal form. Here we are violating this first normal form. So what we'll do, we have two numbers here in this table. So what we make, we'll just divide, we just decompose this phone number, this attribute into multiple attribute. How? Employee ID, then employee name, then phone number. Phone number 1 I will do, then the phone number 2 I will do, and followed with salary, then city, then state. So here we have to just place employee ID 10, Ram 555, 888, 30K, Bangalore, Karnataka, right? So here we have multiple values, so we're just creating the two phone numbers. For example, if it's having a 10 phone number for the same employee, we're going to decompose that attribute into 10 sub attributes. There we're going to place the new values. This is the third technique. The first technique, we're just going to create a new tuple for the multiple attributes, and we're going to decompose the composite attribute into different attributes, different sub attributes. Next, in second technique, we are making the separate table for the multi attributes, and the third technique is what? We're going to decompose the multivariate attribute into number of sub attributes. There we're going to place the value. Among these three techniques, which one is the best one? We can easily say that second one, this part. So making separate table, this is the best technique of applying to the any of the table if we are using a first normal form, because we are creating a separate table. So by creating separate table, there multiple times no need of adding the same values, and if we want, with the help of primary key and foreign key, we can join these two tables and we can make the entire table. So among these three techniques, we can easily say the second technique is the best method to apply a normal form on the attribute. So what first normal form says, in the first normal form, we have to ensure that the table should not have a multivariate attribute and composite attribute. And each value in the table should have an atomic value. Atomic value means single value, right? Single value. We should not have any other multiple values in the table. In the first table, in the first technique, if we make this, if we make a multiple value, if we create a multiple tuple with the same values, means there we're going to hit this employee ID. Nothing but insertion anomaly we're going to face. So what we have to do to avoid that one, we have to combine that attribute with the other attribute to make it as a primary key. Then that issue will be resolved. Second technique, we're going to make a separate table. Then we're going to give the primary key of the parent table, and it will be the primary key has in the new table. Make it a separate table. And the third one, we're going to decompose that attribute into multiple attributes so that we can easily add the values. This is what the first normal form states. And moreover, if we ask in examination, if this table is having a first normal form, obviously the table should be in the first normal form, because while converting from ER diagram to relational schema, we're going to apply this step, the first step. That is, we have a multi-attribute step, right? We're going to create a separate table. So all the database is having it will achieve a first normal form. If it is not, we have to make it into a first normal form. This is regarding the first normal form.